From space, we can see the scars from much bigger impacts on Earth. This one in Canada is 60 miles across. The effects of a similar collision may have wiped out the dinosaurs. The young Earth was once completely covered by impact craters, but most of them have been erased by the powerful forces which keep changing the face of our planet. From orbit, we see evidence for the most astonishing geological discovery of our time. The Earth's crust is broken into about a dozen moving plates. Here, a giant crack extends out to the right from the Sinai Peninsula through the Dead Sea. In a closer view, you can see how the Sinai, shaped like a triangle, has wrenched away from Saudi Arabia on the far right. The rift that opened between them lies under the Gulf of Aqaba. Most of the rifts are on the sea floor. To search for them, we need vehicles similar to spaceships. We are on a journey 2 miles down to the very bottom of the ocean. We will enter a world that has never seen sunlight. And yet, the ocean floor is alive with exotic creatures. They thrive on nutrients in the water, which is heated by the Earth's great furnace beneath. Here in mid-ocean, at the boundary between two plates, molten rock pushes up from the interior. These lava chimneys are actually miniature volcanoes. Just as one of the Earth's systems recycles water, another recycles rock. As new crust is added to the Earth's surface here, the other edge of the plate, perhaps thousands of miles away, sinks back into the Earth's interior. As it melts, volcanoes erupt. This is Sakurajima volcano in Japan. You can see its smoke all the way from space. Here, two great plates are slowly crushing together, pushing up the Himalayas, the highest mountain range on Earth. From just beneath us, the snow-capped peaks stretch over 1,000 miles towards the horizon on the left. Almost all of North America, here on the right, lies upon a single plate. On the left, the Pacific Plate is sliding northward past it at the stately pace of a ½ inch per year. The Gulf of California, in the center, marks the boundary between the two plates. Along this boundary, the infamous San Andreas Fault runs northward. Using satellite pictures, a computer can take us on an imaginary flight along the San Andreas. The actual height of the terrain has been exaggerated to accent the network of valleys formed by the fault's many traces. As the two plates slide past one another, they lock together in some places. The strain builds. Near San Francisco, the strain reaches the breaking point. Something has to give. And when it does, we are rocked by an earthquake. Magnified by the computer, first a sharp wave traveling at 10,000 miles an hour moves out from the epicenter. Then comes a series of rolling waves. These inflict most of the damage.
Efforts to rescue came last night. All sorts of people, cops, firemen, people right here in the neighborhood, risk their lives to rescue strangers.
Everything started shaking, and I started running. I didn't know where to run because I was getting too scared, and my mom couldn't get me because the floor was moving too hard.
Some buildings, though still standing, had to be demolished. In time, the houses and highways are rebuilt, better designed to withstand the next earthquake. People will always be subject to nature's powerful whims. In Japan, another fault zone, millions live with the same uncertainty. One day, almost certainly, we'll learn to predict earthquakes. But in the meantime, we try to live in harmony with our sometimes turbulent planet. After each assault, we pick up the pieces and carry on. And sometimes we wonder if there could be any other place as wonderful in all the universe. But now a new force, as threatening as any in nature, has begun to change the Earth. We are that force. To our ancestors only a few centuries ago, the forests, oceans, and skies seemed vast and